Hi guys, so today we'll be solving this problem called most frequent subtree sum. In this problem, we've been given a binary tree and we need to return the most frequent subtree sum. If there is bit a tie, return all the values with highest frequency in any order. The subtree sum of a node is defined as the sum of all the node values formed by the subtree rooted at that node. Basically, let's try to understand from an example. So first example is 5, 2, and -3. In this, we've been given this tree, and it's a binary tree, and we have, let's try to find the subtree sum of it. So we have 1 is 2 is the sum of this left subtree. 3 minus 3 is the sum of the right subtree. And also this entire tree is also like a subtree, right? So the addition of 5, 6, 7, 7 minus 3 is 4. So that's the total sum of each subtrees possible in this particular binary tree. If we see the frequency of each one of them is 1, 1, and 1, right? So we know that the frequency of all of them are equal. So we will be returning all of them as the answer. Let's try to see the example 2, which we have 5, 2, and -5. So in this, uh, this is a subtree 1, which is 2. This is a subtree 2, so which is -5. And then entirely, it is 5 minus 5 is 0 plus 2, 2, right? So if you see the frequency of 2 is twice, right? So 2 is actually occurring twice and -5 is occurring only once. So the frequency is greater of 2 than -5. That's why we only return 2, right? And that's the answer for this problem in this example, basically. So that's what we need to do. We need to get the subtree sum. And once we get the subtree sum, we need to see what is the maximum frequency of the subtree sum, which is occurring the most number of times. And we need to return that. So that's the idea. Um, After this, what will be the approach for this is we just need to traverse through the tree, and we need to collect the subtree sums, possibly like a pre-order traversal. So every node, we'll go to that node and we'll tell that, hey, give me the subtree sum of that node, and from there we'll actually compare to the maximum frequency. So we'll kind of keep like a local variable to track the maximum frequency, and from there we'll actually just return that from and like basically track it out and return that as an answer. Let's get to the coding part. That will be more clear there. So first of all, we'll maintain a max frequency, which will help us denote the maximum frequency of the entire subtree sum. And then we'll keep a sum frequency array, which will basically, it's a map which will store the subtree sum and their frequencies, right? Once that's done, we'll actually have a pre-order traversal, you know, function which will basically pass which will pass as root, and there it will basically compute the maximum frequency and get us the value. Once we get the value, we actually have to return the maximum frequency sum. So that will be an array, and I'll just iterate through the max frequency, sorry, sum of frequency, and I'll do something here. So let's avoid that right now, and let's get to the pre-order traversal part first in order to understand what will be the compute part. So pre-order traversal root, right? And from there, what we'll do is if root is none, then we just return, right? Otherwise, we'll do something here. We'll do something here, and then we'll all actually call pre-order traversal root dot left and pre-order traversal root dot right. Um, Once that's done, in the compute part, what we'll do is we'll get the current sum of the root of the subtree, right? So we'll actually create a function called find tree sum, which will give us the sum of the current root node, right? So we'll get it from here, find tree sum, and we'll have this root. So in this function, it's very simple. If root is none, then just return 0. Otherwise, return root dot value plus find tree sum root dot left plus find tree sum root dot right. So that will be the idea to get the sum of the subtrees. So once that's done, once we have the current sum, so current sum is we'll find tree sum root, right? Once from there, we have to update the sum frequency, right? So we have this map, right? So we'll actually go to that frequency of sum, sorry, current sum. Actually, current sum is equal to sum self dot sum frequency dot get current sum, or get a 0 instead and add a 1 to it, right? That would be idea for getting or storing the subtree sums in the map called sum frequency, and we'll keep on updating it as and when we get a similar sum, right? So max frequency will also be updated. So max frequency is between max frequency and the current sum frequency of current sum, right? That will be the max frequency. So this will be self and self and right. And once that's done, we come back, we pre-order traversal is actually populated the map, and we also know the max frequency possible of the subtree sums, which is the max frequency. So we iterate through the sum frequency. We'll check if self dot sum frequency of sum is equal to max frequency, right? So basically, if uh, if there are multiple subtree sums which are having the same number of frequency, which is equal to the max frequency, then we'll add it to the max frequency sum array, right? So that will be the answer. And once that's done, we'll just return the max frequency sum array from there. Let's run the code to see if everything is working fine. Yeah, so right, this is actually like a not like a list, it's a map. So that will update. Some frequency is not defined. Okay, self dot some frequency. Yeah. So all of this will actually be updated to self dot max frequency. That should work. Yeah. And we run the code. That's exactly cool. So I hope you guys understood and liked the video. Thank you.